Hey guys, in this video we're going to be talking about different parts of data. So we're going to be talking about population, sample, ways to collect data, and how to use that data to make inferences. So in order to be able to do that, we need to understand a few key vocabulary words. So first of all, a population is what consists of all the members of a group of interest about which data will be collected. So our first important word is population. Now, from that population, you get a smaller group called a sample that is sometimes collected to represent the population. The sample is used to draw conclusions about the entire population. All right, now there are three types of studies that you could use in order to collect data. The first is called a survey. So that is a type of study that gathers data from a sample just by asking questions. So that is probably the most common type, or the type that you hear about the most. The second type is called observation. And this is done by observing members of the sample without intervening or manipulating what is going on in front of you. And the last type is an experiment. Okay, now that type is exactly what it sounds like. You're going to assign a certain condition to a smaller group from the sample to see how it affects each group, and then draw conclusions based on that information. All right, so let's go ahead and let's take all those pieces of information and apply it to some examples. All right, so for each of the following examples, we're going to determine what the population is, what the sample is, and what the type of study was. So the first one says, WHJE is interested in the type of music that CHS students listen to the most. Members of WHJE asked students entering each cafeteria in the school what their favorite music genre was and recorded the responses. All right, so the population is the overall group that they're trying to find information about, and that would be CHS students. They want to know what is the favorite type of music of all of these students. Now, the sample is going to be from the students that they actually get the information from. So, students who responded to WHJE. Okay, so that's where the data is actually coming from, and they represent all of the students in the school. Now, the type of study is, let's see, they are asking students a question, so that makes this a survey. Let's try another. Ms. Green was curious about what effect completing homework had on the outcome of tests. She formed two random groups in each of her classes. One group was randomly assigned homework for the entire unit, while the other group was assigned no homework. Once the test was given, Ms. Green compared the test scores of those who completed homework with those who did not. All right, so then that means the population here is going to be all students, or students in Ms. Green's classes. Or all, we should say all students. Because I think she is trying to talk about how it affects all students. Now, the sample are going to be the students in Miss Green's classes. Now, if you look at what she did, she gave one group in each class homework while the other group did not get homework, and then compared the test results based on that information. That makes this an experiment. And that would be it for this one. Let's try another. All right, Popcornopolis is a shop in the mall that sells different flavors of popcorn. The manager of the store was curious about which odd flavor of popcorn customers were most likely to try. The manager set out free samples of s'mores-flavored popcorn and free samples of taco-flavored popcorn. He then kept track of how many of each type of popcorn people in the mall selected to try. All right, so the population here, this is a little bit weird, so maybe let's start with the sample. So the sample is going to be selected popcorn here, in this case, s'mores and taco-flavored popcorn. So selected samples. So it's taco and s'mores. And these two types belong to the bigger population of odd flavored popcorns. Okay, now for this one here, the manager, all they did was observe which of the popcorn was taken for the free samples. So that means this is an observation. Now, there's another way that you could look at this too. Instead of thinking of the sample and the population being popcorn, which is a little bit weird, I think it might be easier to think about the customers themselves. Okay, so the sample is going to be customers who took the free samples. And they represent the larger population of all customers. It could be looked at either way. All right, so that is different ways to collect data and what a population and a sample are. So basically, a sample is a smaller group of the population, so they should be the same thing. So if you're going to say, for instance, that the selected samples, the random flavored popcorn here is your sample, that means your population has to be the odd flavors of popcorn. You can't have popcorn as your sample, but then customers as your population, because those are two different things. Okay, so you have to be careful when you're doing that. And then you have 3 types of studies to choose from. All right, so let's talk about how to use your data to make inferences. Okay, so we have an example here, and we're going to take that example and we're going to answer questions about it. All right, it says a survey of 35 adults and 35 children was taken at a local farmer's market. One of the farmers asked each of them to select their favorite fruit from the types of fruit available for purchase. The results are shown to the right. Okay, so it says how many people were surveyed in total. All right, so we have to take a look here. Here's our graph, and we're going to take a look at the number of people that did each of these different types of fruit. So for bananas, the adults chose in between 4 and 6, so that means 5. The kids, there were 15 of them that chose bananas. For apples, adults were 6. And kids were 7. For oranges, 8 for adults and 5 for kids. For grapes, it was 2 adults and 4 kids. For melons, it was 10 adults and 5 kids. And for pineapple, it was 4 adults and 1 kid. Okay, so we're going to add all this up. So bananas, there were 20 people. Apples, there were 13. 13 for oranges, 6 for grapes, 15 for melons, and 5 for pineapples. All right, so we have 20, 30, 40, 50, 60, 72, it looks like, if I can do math correctly. So 72 total people were surveyed. Okay, now it says approximately what percentage of the sample prefers oranges. All right, so it doesn't specify whether it's adults or children, so we're looking at both. So that means there were 13 people that preferred oranges. So that would be 13 out of 72. And then to find the percent, what we're going to do is we're going to divide 13 by 72 to find out what that answer is. And of course, I don't have my calculator near me. So to find your answer for this one, guys, check out the answer key on Canvas. So all you would do is 13 divided by 72, and then either move the decimal 2 places to the right or multiply that by 100 to get your percent. Okay. All right. If 250 people went to the farmer's market that day, approximately how many would say they preferred bananas? Okay. So, bananas, there were 20 people that said they liked bananas. So that's 20 out of 72. So we're going to actually need a calculator here. So I am going to go fetch one. So let me go do that really quickly, and I will be right back. Okay, so here's my calculator. So let's go back and finish letter B. So to find your percent, you're going to do 13 divided by 72, which is 0.18, and then a bunch of numbers after it. So if I'm going to round, it's going to be, I'm going to multiply by 100. Oops. So let's go back. 13 divided by 72 times 100 gives me 18.1-ish percent. So we'll just say 18%. So 18% of the sample preferred oranges. So let's decide, or not decide, but calculate what percentage preferred bananas. So this time it's 20 divided by 72 times the 100, and that is about 27.7%. So we're going to round that up to 28%. So 28% prefer bananas. Now that's out of the sample. So if we're going to say that 250 people went to the farmer's market, and we're assuming that 28% of those people prefer bananas, we're going to figure out exactly, or not exactly, but approximately how many people would say they prefer bananas. So 28% as a decimal is 0.28. We're going to need that. So we're going to do 0.28 times the number of people that were at the farmer's market, which was 250, to figure out approximately how many people would say bananas. And that is 70 people. So 70 people. So we can use these percentages from our samples to figure out how many people, in this case, how many people would say that their favorite fruit is bananas. And you could do the same thing for any of the fruits that are available here. Okay? All right, so let's try another. It says, the cafeteria manager of a high school took a poll of 150 randomly selected students to find the most popular lunch item offered in the school cafeteria. The results are shown in the pie to the right. So here's the pie that they're talking about. So 12% said they liked corn dogs, 18 said cheeseburgers, 30 pizza, 12 tacos, and 28 said spaghetti. Okay. So how many students from the sample said cheeseburgers were their favorite? Now, it's important to understand how many people are in the sample. So she took a poll of 150 students. So what I'm going to do is I'm going to take the percentage of the number of students that said cheeseburgers, which was 18%, and change it to a decimal. So 18% is the same as 0.18. I'm just moving the decimal 2 spots to the left. And then I'm going to multiply that 0.18 by the number of people in the sample, which in this case is 150. So 0.18 times 150 is 27. So that means 27 students said cheeseburgers were their favorite from the sample. And we're going to do the same thing, but for spaghetti. So there were 28% of students that said spaghetti was their favorite. That's 0.28. So this time I'm going to do 0.28 times the 150 students in the sample to figure out how many said spaghetti. So 0.28 times 150 is 42. So 42 students chose spaghetti. Okay. Now it says, if there are a total of 4,500 students in the entire school, how many will probably say that they prefer corn dogs? So what we're going to do here is we're going to use the results from our data, from our sample, to predict how many students in the entire school will say that they like corn dogs. Well, 12% of students like corn dogs, so 12% is the same as 0.12. So I'm going to take that 0.12, multiply it by the number of students in the school, which is 4,500, to figure out about how many students would say that they prefer corn dogs. So 0.12 times 4,500 is 540. So 540 students from the total would probably say that they prefer corn dogs. All right, last one. Claudia says that 540 students in the school will say they prefer tacos at lunch. Is she right? And how do you know? Okay, there's a couple ways to go about this. We could do all the work like we did above here and figure that out. But if you notice, tacos is also 12%. But we already did the work for 12% because That's the same percentage for corn dogs. So I can assume that, and not assume, I know that the same number of students that like corn dogs are going to say that they like tacos. And that answer was 540 students, which is exactly what Claudia said. So I'm going to say Claudia is right. Because 12% of the sample preferred tacos. So we can assume %12 of all students also prefer tacos. 12% of 4,500 is 540 students. And there's probably different ways that you could say that, but it's completely up to you. Okay? So that would be it. I know that Claudia is right. Let's try one more. Okay. A group of randomly selected students were asked to pick their favorite activity in gym class. The table to the right shows the results of the survey. Okay, so the table didn't come out very well, but on the left side here, you have the sport that you would play in gym class, and on the right side, you have the number of students that said each one was their favorite, okay? So it says, what percentage of the sample said that team sports were their favorite? Now, in order to figure out that percent, we need to know the total number of students in the sample. So what I'm going to do is I'm going to take this and I'm going to add it up together. So 9 and 1 is 10, and I know 17 and 13 is 30, so that's 40 total students. So out of those 40, how many of them said that team sports were their favorite? 9. So I'm going to do 9 out of 40, and let's figure out what percent that is. 9 divided by 40 times 100 is 22.5%. You could also put 23% here. That would be fine. All right, what percentage of the sample said that racket sports were their favorite? Only 1 out of the 40. So 1 out of 40 is 2.5%. Okay, now, if there are 528 students in the school, how many are likely to say that track and field is their favorite? Okay, so first we need to know the percent of the sample that would say that track and field is their favorite. So that's 17 out of the 40. So 17 out of 40 is 42.5%. So 42.5%. So that means I would do 0.425 times the number of students in the population. So that's 528. To figure out how many are likely to say that track and field is their favorite. So if I take that 0.425 and multiply by the number of students, which is 528, I get 224.4. Now, I can't have 0.4 of a student, and I cannot round up because that would not be accurate. So I'm going to say approximately, so you can use a squiggly equal sign like this to mean approximately 224 students. Okay. Now, how many students in the population are likely to say that bowling is their favorite? So from the sample, 13 said bowling, so it's 13 out of the 40. So 13 out of 40 is 32.5%. So I would do 0.325 times the number of students, which is 528. So 0.325 times 528 is 171.6. So again, approximately 171 students. And that is how you would use data to make inferences about a population. And that's it for today. That's all we need to know about population, sample, ways to collect data, and how to use that data to make inferences.